Corruption, it's a problem that's as old as humanity itself. We've tried to solve it with laws, with more oversight, with promises from politicians, but it never really goes away. But what if the problem isn't a moral one? What if it's a technical one? What if we could design a system where corruption isn't just illegal, but literally impossible? Okay, let's dive into this pretty radical idea.
This right here, this is the core metaphor you've got to get. Right now, public money is kind of anonymous, it's untraceable. Once it's allocated, it pretty much disappears. But programmable money, it changes the entire game. It's money that has rules baked directly into its code. And believe me, that completely flips the power dynamic between us, the citizens, and the state.
So let's really frame the problem here. There's this concept we're exploring today, we'll just call it the laboratory. And it argues that corruption isn't really about a failure of character. Nope, it's a failure of technology. It's basically a bug in the financial operating system of the government.
I mean, think about it. When a government sets aside, say, $1 billion for a project, that money just flows through countless hands, departments, contractors, you name it. And without perfect, real-time tracking, it is incredibly easy for those funds to get diverted, skimmed off the top, or spent on completely the wrong things. The money itself has no clue what its purpose is. It's just dumb.
And this is where the big shift happens. Instead of the state acting like some clumsy manager just, hoping people do the right thing, in the laboratory, the code doesn't just help out, it actively enforces the rules and the efficiency. The government stops being this passive bucket of money and starts acting like a really smart, data-driven investor in its own country.
All right, so how does this actually work in practice? Well, let's look at one of the biggest sources of corruption out there, government contracts. This is where cronyism and all those backroom deals really thrive. So the laboratory's first target is to just automate this entire process.
The solution is this really cool three-step process built on what's called a smart contract. You can think of it like a digital vending machine. It only gives you the product, in this case the payment, when the right conditions are verifiably met. So first, all the bids are submitted completely anonymously. No names, no company logos, nothing. Second, an algorithm, not a committee of politicians, analyzes all the bids and picks the best one based on pure data. And third, the payment gets locked into that smart contract and it only gets released when the job is verifiably done right.
I mean, this is a fundamental shift. We're moving from a system that's based on who you know and what political favors you're owed to one that's based on pure objective math. You can't bribe an algorithm. You can't have a friend hiding inside the code. All those delays and human biases are just, they're engineered right out of the system. And here's how this plays out in the real world. Just imagine sensors embedded in a new public bridge, and they confirm that the contractor used cheaper, weaker concrete. The smart contract doesn't wait around for a lawsuit or an inspector's report. Boom, it instantly freezes the payment or applies the penalty. The code is the law, and its execution is totally automatic. Cheating becomes a technical failure, not some moral loophole you can wiggle through. Okay, so smart contracts solve the problem of how we award the work. But what about the money itself? This is where the laboratory introduces its most powerful and honestly its most radical innovation. We've all heard the fears about central bank digital currencies, right? CBDCs, digital versions of a country's money. The big concern is that they'll let the government track every single purchase you make. Well, the laboratory flips that idea completely on its head. It creates an inverse CBDC, where the entire point of the technology is to give citizens a perfect, unblinking view into how the state spends every single dollar of public money. Let's be crystal clear about this power shift. In the standard model that everyone's worried about, surveillance flows from the top down. In this inverse CBDC model, surveillance flows from the bottom up. It's a tool for radical, enforced transparency. So how does this actually work? Well, the money is programmable. So if a budget allocates funds for, say, grade A steel for that bridge we were talking about, the digital currency itself is encoded with that rule. When the contractor goes to the supplier and tries to buy cheaper grade B steel, the transaction is just rejected right there at the point of sale. The money knows what it's for, and it just refuses to be spent on anything else. Now, of course, this brings up a huge question. What about privacy? And the system is designed with this crucial firewall. This intense tracking only applies while the money is considered public funds. The moment it's paid as a legitimate salary to a construction worker or as profit to a company, that tracking protocol is completely wiped. The state has zero visibility into what that worker buys at the grocery store. Public function is totally transparent, private life stays private. So we have contracts that can't be cheated and money that can't be misused. The final piece of this puzzle is to make the entire system completely transparent so that everyone can verify that it works exactly like it's supposed to.
This is a foundational principle from the world of open-source software, and it's basically the security philosophy of the laboratory. What it means is, if you let enough smart people look at the code, somebody is going to find any mistake, any bug, or any hidden backdoor. Secrecy is a weakness. Transparency is a strength.
So what does this mean? The entire digital architecture of the state is made public. The code for the smart contracts, the protocols for the inverse CBDC, even the algorithms used in the justice system, it's all open source. Anyone can download it, inspect it, and look for flaws. There are no secret government black boxes.
And what this does is it creates a permanent, global audit. The state actively encourages everyone, from university researchers to independent security experts, to try and break the system. And why would they do that? Because it makes the system stronger. If the government ever tried to slip in a backdoor to benefit itself, this huge global network of watchdogs would spot it almost instantly.
So all of this builds to a really fundamental shift in how we think about governance. This isn't just about installing some new software. It's about upgrading to a whole new philosophy of trust.
And this is the crucial takeaway. We stop relying on the promise of a politician to be honest. We stop hoping that a good person gets in charge. Instead, we rely on a system where dishonesty is technically, physically impossible. Justice and fairness are no longer just matters of opinion. They become verifiable, auditable algorithms.
And that really brings us to the ultimate mantra of this entire system. It's a call to move away from faith-based politics and toward evidence-based governance. Don't just trust the promises, check the code.
This model presents a really powerful way to manage a state's finances and its administration. But it leaves us with one final, pretty provocative question. If we can use code to manage money and contracts based on merit and performance, what would happen if we applied that exact same logic to political power itself?